Yeah, so I'm a mechanical engineer by trade, and it's very unusual for me to obviously come to a tech conference. But I spent 4 years designing parts for F1 cars predominantly, and you'd be surprised how much inefficiency and how much difficulty there is in the most high-tech, most glamorous industry in engineering. So I sort of got obsessed with this idea of how do we revolutionize the way we run our processes in manufacturing, and also how we optimize going forward. So I think the first thing that we need to sort of address is some context into engineering. Obviously, I imagine many of you aren't too familiar with some of these concepts, so forgive me for the sort of upfront heavy context dump. But effectively, AI manufacturing futures are inevitably interlinked at this point. AI requires an extremely high industrial output of many vital components, GPUs, etc. The computational problem for AI is massive. At the same time, how do we reach that new level of efficiency in manufacturing is solely in the hands of what AI can provide us going forward. So sort of to look at potentially where the future could be, we sort of got to consider manufacturing's history. Most people know what the Industrial Revolution is and think, oh, that's sort of, we did that, and then manufacturing sort of stood still. But in reality, it's been constantly evolving ever since its inception. You think that most factories before run on steam, then electrification happened, and this allowed mass production, but also a level of precision that actually led to creation of the ability to create sophisticated components enough to actually make computers. This in turn brought computers back into manufacturing and revolutionized the way we manufacture. So this is a constant loop through time, and we're now looking at today facing Industry 4.0, which is this concept of cloud compute, process automation, and AI integration into manufacturing. So this is sort of what we're looking at now, and sort of where we're sort of exploring today. Sort of focusing a bit on the UK, which is obviously my focus and the problem I'm trying to solve. UK manufacturing has been a bit bleak. I think anyone that's survived the 70s will know this. However, this is sort of an untrue opinion. It's sort of mainly focused around large volume manufacturers. And this is a lot of our large manufacturing operations have left the UK in the last 50 years. And this is mainly to do with, as you saw in the previous slide, Industry 3.0, the introduction of computers. This put a massive positive push towards centralization and large volume manufacturing. This is because every time you fix a process in place, computers could repeat that process as many times as you want. The UK is actually known for its high value and low volume manufacturing. So this means that every time we make something, it's usually new. So think of an F1 car. When is it ever the same, right? It's rarely the same race to race, let alone year to year, month to month. So this is the area that we thrive in, but also has benefited the least from recent innovations in technology. So sort of to look at why that is, we got to think of, sort of as I was alluding to earlier, how operational complexity and how planning gets harder the more you add in these variables. So if we look at some of these slides here, you can see on the left here, job shop and batch manufacturing have the highest cost, design flexibility, and product diversity. These are the main drivers of operational complexity in manufacturing. And as it happens so, the UK sits, most of our manufacturers sit between job shop and batch. So we're sort of playing manufacturing on hard mode, and I think that's sort of why we're struggling so much. So if this problem's so obvious, everyone knows we're struggling, everyone knows it's been happening for a long time, why has no one solved it yet? And I think the main reason no one solved it is because modelling manufacturing is extremely complex and extremely difficult. It's the main obstacle that stopped anyone from progressing past sort of the standard models we see today. As you can see here, this graphic on the right, you have 4 different types of process modelling. Manufacturing firmly sits in this complex type, which means you don't know what you don't know yet, because in the sort of job shop, batch manufacturing, you don't even know the product you're going to make until someone asks you to make it. So this is how we've got a... Oh, sorry, is it cut out? Oh, good. Yeah, so this is the sort of problem we're trying to solve. So how do you make a manufacturing model? The aim of a manufacturing model is to directly represent the manufacturing process that occurs step by step. And this is sort of colloquially known as a digital twin. So what we're trying to do is create an accurate digital twin. But however, due to computational limitations of previous technological advances, most of these providers have tried to avoid chaotic or complex systems and try to make them as simple as possible. Now, simple actually is it's actually a technical term, meaning that you know every single step along the way before it happens and it will never change. So you have to think directly coded systems before AI, before orchestration. You have to write every single line of code of every single thing that's going to happen before you start. So you can imagine you work for an F1 supplier like I did, and they changed their design 2 weeks after you started making the first one. How can you possibly code that in time when you've got 2 weeks to make it? So this is the problem we're facing. Now, I believe that AI and orchestration combined are the solution for this, because that reaction time is so much more reduced. So there's a little bit of context there. I wanted to sort of, hopefully that makes sense, engineering, that's sort of the basis there, but we'll move into some AI, so everyone likes this bit. I believe that AI alone is not enough to solve the problem we have with manufacturing in the UK. As I've stated quite strongly here, I believe AI only has two applications. It's to automate ordinary processes that anyone could do. These are the jobs that everyone's scared of losing, but I generally think these are the jobs we could avoid doing. No one needs to be filling out forms all day. Where AI really adds value is the application of extraordinary. AI can't produce extraordinary outcomes, but it can definitely get you to an extraordinary outcome quicker. So this is why we want to use orchestration to amplify the power of AI into manufacturing to allow us to get to our goals quicker and meet those deadlines. So this is what's in the adaptation of AI alone cannot address the requirements of production planning. One thing that really troubled me early on when I was looking into this is that all manufacturing systems are closed systems. There's a lot of IP, there's a lot of internal property that can't be shared. So in any AI in a production system will have to be in a closed system. This means that AI can't interact with the outside world and it can't tell the outside world what it's doing either. So what does that mean for an AI in a closed system? This means that effectively we need to understand exactly everything that AI is doing to know what's going on. So one of the things that I got really obsessed with this concept we had in engineering called Excel shamanism, which is a bit of a tongue-in-cheek phrase, which basically means that people worship their Excel spreadsheets that got them the answer they wanted and never actually knew what the Excel sheet did, but they got their answer, they were happy. And I think what we're in danger of now is that we're going to enter an era of AI shamanism, where we go, AI, do this thing I want. It goes, this is the answer you want. And you go, that's amazing, I love that, that's a great idea. And as AIs are trained on outcomes, not on process, they will ultimately aim to give you the answer you want. So it's a dangerous feedback loop there, especially in a closed system. So that's all what I'm saying here on that point there. Isolation is a big issue in AI. Another thing that you need to consider is that an AI is only as good as the information you allow it to access to. So again, in a closed system, you need to constantly be gathering data to feed it, because the outcomes it will give you are directly proportional to the information you put in. So sort of looking at the solution I've been alluding to, which is AI combined with orchestration. So what is orchestration? My definition of orchestration, there's lots going around, it's relatively old but kind of new concept emerging now with AI. I would define it as the systemizing of manual and automated tasks with the aim of creating more complicated workflows, predominantly using visual aids in order to achieve that. So one of the big upsides of orchestration is that every step is monitored, mapped, and contained. So if you want to put AI just solely in this one step, it can exist in there, complete its function, give you the output. The AI also has access to all the previous steps and everything it needs to know before that stage. So one of the things that really excited me about orchestration, which is why I saw it as the solution for this problem, was that orchestration is defining a series of specific steps to reach an end goal. And you think, what's production? It's following a series of procedures and steps to reach an end goal, which is a product. So in a way, orchestration is also a metaphor for production, especially in the UK where it's constantly changing. So I wanted to sort of look at some examples of orchestration, because I understand if it's not a word that you're familiar with, you might not necessarily on the face understand what it means. So I've got some examples here. So for example, this is an orchestration of an invoice robot. So all these steps here are what you need to do in an invoice. As you can see, you've got a set of decisions, an invoice agent, which is an AI agent, which actively interacts with the data set and then basically provides you with a correct invoice based on the inputs you've put in. We have another one, which is another simple example, is a leave request. Again, but this is done through an AI chatbot. So with orchestration, we can just drop in a chatbot and say, well, let's talk to this chatbot about your leave, and the chatbot will decide whether you've provided the significant information that grants you the leave request that you want. The final example is from my company, DRS. It's a really complicated looking one. Basically, this is what maps a stocking decision based on a works order. So works order of engineering is an order of works. It's something that goes, I'm ordering you to make something. So this is the process flow that's itemized and decides exactly where that stock's coming from, whether it's subcontracted, sub-ordered, or manufactured in-house. So the main other benefit of orchestration is the monitoring. So as you can see here, whenever we do anything on an orchestration platform, we have access to all the success and run data of any AI that's executed, as you can see on this left-hand image. We also have access, in DRS again, is the example. This shows the exact processes that have triggered. So these are steps in a production process that define exactly each step taken, if there's success, if it's being passed to a human, what human's doing that task, if it's been passed to an AI, what they decided and why they decided it. So you get this full map of processes that's constantly learning from itself. So it gets really quite impressive after you feed it more and more information. So sort of what I wanted to sort of generalize a little bit was talk about how AI and orchestration outside of production has benefits to solving two main problems, which is externalities and novelty. Now, anyone that's worked in system design or with complex systems know that these are the two main issues you will predominantly face when designing a system. So an externality in a complex system is a vector or variable acting on a system that the system itself does not recognize. So the classic example of this comes from economics, and this is that if a manufacturer has pollution as a byproduct of its production, this pollution affects the local area but doesn't affect the manufacturer. So the manufacturer's models, they will continue to excessively pollute in order to optimize off their own privatized costs without affecting the local environment. So traditionally, the government picks up social costs and the manufacturer doesn't actually get any effects of that. So this is obviously a big environmental talking point, but it says it lightly. So if an AI was given this model that the private company works off, an AI would actually choose to pollute the river more than the private company is doing now. So this is it's a very good example of AI only knows what it's given, right? So with orchestration, we have this constant map of what the AI has been given, what it's been allowed to do. And the human interaction with the AI is what's really important. So that iterative process allows us to go, okay, well, this AI is deciding that it really likes polluting this river. And as people, we know there's something wrong with polluting that river. So what variable can we adjust? What information can we allow it to have that will allow it to iteratively improve that process over time? So if anything, the induction of AI with orchestration is a very good sustainability goal in production, which is something I'm quite passionate about. So sorry for going on about it, but that is quite an interesting outcome. The other concept is novelty. Now, we all know about novel from coronavirus. It's quite a big word used for a while. But in reality, novelty is a really big issue in process design. Any time where your inputs don't match your outputs, their decision-making freezes. This is usually when you defer up to a board member or a CEO, just please make a decision, because we no longer have procedures as a business and as employees to solve this problem. So novelty is a huge problem. But where does novelty really come from? Novelty basically means that you had enough externalities, as I explained earlier, that you can no longer map your processes, that you can't expect, the outcomes are no longer expected. So what orchestration allows you to do is slowly chip away at those externalities, and in the end, you can actually realize that your novelty was never novelty in the first place. It was just a series of variables acting against each other that you couldn't understand before looking deeper. So an example of this, problem is with novelty and externalities is once you explain them, they're no longer novel or externalities. So it's kind of once you explain, well, that was obvious. But a good example of this is a company we worked with who did anodizing. Well, I say we, I said in my previous role. They did anodizing, and they took in two main considerations for how long that process took. It was color and temperature of the room. Now, they had a variance of about 20% on their time for that procedure. And every time we rang them up and said, how long is this going to take? They said, it might take 20 minutes, it might take 22 minutes. And the problem that had is that they didn't know. So their whole planning process stood still and they were constantly adjusting their values. What they actually found later on is that if they considered humidity and dry volume of the room, which basically means how dry is the room, how big's the dry room, they actually could narrow that down by 90%. So that thing that was novel, that thing that we couldn't predict, suddenly becomes predictable and it becomes a massive part of your planning ecosystem. So this is what orchestration allows us to do. You constantly have access to the information of why things run, what happened and when they happened, and that constant feedback loop allows you to collect data that you wouldn't even expect before. So looking forward, so the implications of this all together. I've listed a bunch of reasons there, but for time I'll only pick a few out. The sort of things for production specifically, if you think if we have orchestration, we have a fully mapped process, and AI can sit on top of that process and start making planning decisions based off decision criteria. So therefore, if something comes up, someone's sick, something's late, AI can organically and dynamically switch between which production is going to be run on that day. If you think about, we have all these reprogrammed machines right now, CNC machines that can do multiple things, but their main restriction is we don't know what we can put on them when. So if you have an AI on managing the production planning, you think of the infinite manufacturing possibilities that can come together by combining a reprogrammable machine with an adaptive planning process. The actual output is theoretically limitless if it can decide when it needs to make something, how it needs to make it 24 hours a day. The monitoring of every microdetail of every complete process could actually lead to design, sustainability and efficiency innovations in engineering that we've never seen before. Because often we make a product and we don't know the downsides of it for 10, 15 years. I worked in F1 and you often didn't understand when things went wrong until you saw the broadcast of the driver who happened to be driving your car with your brakes on, brakes failed, and you go, oh, something happened there. So this is really important, it could save lives theoretically. And the final sort of thing is, well, how many products out there are currently unprofitable because we have limited efficiency, and how many more exciting products could we produce if we just unlocked the capabilities of UK manufacturing with orchestration and AI? So I think that's the bit that excites me the most. And sort of finally, I sort of want to sort of think about, if you could think amongst yourselves and just think in your own head, well, how can this apply to my industry? I think AI and orchestration is not specific to production. I think if anything, production is one of the hardest applications for AI and orchestration combined. I think there are so many more simple, more refined, more known processes in all sorts of business sectors that could benefit from this. And I think as it emerges, we'll see all sorts of companies really capitalizing on this opportunity. So yeah, I think, that's all from me. So thank you guys.